We spent a lot of time on Friday rationalizing denominators, but there's a type of problem that we did not get to. And it's a problem like number 85. So you can ignore the 10 that's on your screen and pretend like it said 85 instead. So if you're wondering where I'm getting this problem, it's off of page 465, which has the square root of 8 over 3 minus the square root of 2. So the first thing I want to point out here is that square root of 8 will break down. And if it'll break down, then we want to break it down. That's what I kept saying earlier in the class today, that if you have a radical that'll simplify, go ahead and simplify it. So the square root of 8 would go 4 times 2, which would be 2 times 2 times 2, which would allow me to pull out a 2, right? So it'd be 2 times the square root of 2 over 3 minus the square root of 2. So now our problem looks like this. And remember that our goal is to remove the radical from the denominator. We don't like that root 2 down there. So, up until now, what we've done is try to just multiply by root 2. Okay, now that's not going to work here. Let me show you why. Don't write this down, just watch for a minute. Let me show you what would happen if I multiplied by root 2. So I'd multiply by root 2 on bottom and top. And when I did that in the bottom and distributed the root 2 through, times the 3, that'd give me another root 2. And then root 2 times root 2 would give me a 2. So even though it would get rid of the second root 2, it would create another root 2. So multiplying by the square root of 2 in a case where we've got a binomial in the denominator does not help. It doesn't do us any good. So we're going to have to use an alternative strategy. So let me go back and erase, because that's just not going to work. We're going to have to do something different. And the question is going to become, what are we going to do to get rid of our square root of 2? Well, what we're going to do is we're going to put this problem on hold. We're going to go off to the side here, and we're going to do a little exploring. Okay, so if you don't want to write this, that's fine, but you need to watch for a minute. Let's say I had something like 4 plus the square root of 3. And let's say for kicks that I, for some reason, just thought, hey, I'll multiply that by 4 minus the square root of 3, just to see what happens. Now, do you see that 4 plus the square root of 3 and 4 minus the square root of 3, we talked about binomials like those earlier in the semester, and we called them conjugates. Remember, conjugates are binomials. They're like, except for the middle sign. One's positive, one's negative. So watch what happens when we multiply this. 4 times 4 is 16. What's 4 times negative the square root of 3? Well, it'd just be negative 4 times the square root of 3. Let's take the root 3 through. Root 3 times 4 is positive 4 times the square root of 3. How about square root of 3 times negative square root of 3? What's that, class? It would just be 3, and it'd be negative. Now, an interesting thing happens. That's right, negative 4 root 3 and 4 root 3 cancel out. I end up with 16 minus 3, which is 13. Why is that significant? Because when I multiplied by the conjugate, I got rid of the radical. Let's see if it works every time. So this time you guys are going to give me a problem. So, Cody, give me a number.
5.
And Sydney, give me another number.
8.
Don't use it. Give me a number that I couldn't break down under a radical.
7.
Okay. Let's say I had square root of 5 plus the square root of 7. Then its conjugate would be square root of 5 minus the square root of 7, right? Let's see if the same thing happens again. If by multiplying by the conjugate, we get rid of the radicals. So here we go. Let's distribute the square root of 5. Hey class, what's square root of 5 times square root of 5?
5.
What's square root of 5 times negative square root of 7? It'd be negative square root of what? 35. Done with the root 5. What's positive root 7 times root 5? Well, it'd be positive square root of 35. What's positive root 7 times negative root 7? Negative 7, that's right. And lo and behold, it happens again. Negative square root of 35 and square root of 35 cancel. And 5 minus 7 is negative 2. So it looks like if you've got a binomial that has a radical in it, the way to get rid of it is to multiply by the conjugate. Did you hear what I just said? So back over here on this problemo, which I'm not finding, where did it go? Here it is. This is where we were at. So if I want to get rid of 3 minus the square root of 2, what I'm going to do is multiply by 3 plus the square root of 2. But if I do it on the bottom, I got to do it on the top. Shamira, I didn't hear what you said. I'm sorry.
You had answered me. I was asking if you did it to the bottom, what you do to the top.
Okay, now let's see what happens on the bottom then. 3 times 3 is 9. And 3 times the square root of 2 is 3 square root of 2. And I'm done with the 3. And negative root 2 times 3 is negative 3 times the square root of 2. And negative square root of 2 times positive square root of 2 would be negative 2. And those do cancel. And in the denominator, I've got 7. So it appears that I accomplished my goal. I got rid of the radical in the denominator. What about the numerator? Well, 2 root 2 times 3 would be 6 times the square root of 2. 2 root 2 times root 2, those two root 2's would make another 2, right? So it's really 2 times 2, or 4. And if I could get anything to factor and cancel, I would, but here nothing does. So we end up with 6 square root of 2 plus 4 all over 7, which is simplified because I don't have a radical in the denominator. How do you like that?
But you, okay, at the top, you said.
Okay, the question is.
Never mind. Okay, I see. The root 2's cancel out, and then, okay, never mind.
So you can tack this assignment onto the assignment from 464. It's 465. And why don't you work on a couple of these, like 83 and 84.